Okay, so let's begin. We are looking at the homework exercise 2.2. Question 2G first. Okay, we have to solve the following inequalities and represent the solution on the number line. So there are two parts to it. First, you need to solve, and then you need to put it on the number line. Okay, so let me just copy this question out to the side. We've got 2 over 7 plus x over 4 less than or equal to 3x over 4 minus 5 over 7. So right now we are dealing with inequalities in fraction form. Our end goal is to eventually get x is greater than or equal to something, or it will look like this, x is less than or equal to something. I'm not too sure yet, but that is our end goal. In other words, I want to make x a subject, and then I need to follow some rules. Everything you do on the left side, you must do on the right side. The inequality sign will remain the same until we are dividing or multiplying by a negative sign. So these are the rules that we need to follow. Everything else will stay the same. And then when you finally get your answer, either this or this, we substitute values that satisfies either of these back into the original inequality. You will find that the left-hand side, we call this the left-hand side, is less than or equal to the right-hand side. Okay, so that's our objective. So we use our everything that we have learned since primary school for this question. Okay, I've got a fraction plus fraction less than or equal to fraction minus fraction. There are many ways to go about doing this. You can choose to combine these two, same denominator, same denominator. After that, combine again. Alternatively, you can start making x the subject. So you subtract 3x over 4 on both sides, and then you subtract 2 over 7 on both sides. So let me demonstrate. My first step, I want to first get rid of the 2 over 7. Minus 2 over 7. I want to remove this. So I do so by subtracting the 2 over 7 on both sides. I'm left with x over 4. The sign doesn't change. It's the same. Because I'm not multiplying or dividing by negative. And then on the right hand side, no change, 3x over 4 minus 5 over 7. Then now I remember to minus 2 over 7. Okay, next step, I want to remove the 3x over 4. So I minus 3x over 4 on both sides. You have to see and be convinced that what we are doing is all very logical, very sequential, nothing fanciful. So x over 4 minus 3x over 4 less than or equal to, now we have negative 5 over 7 minus 2 over 7. Let me just evaluate that quickly. That's negative 1. Okay, now on the left hand side, I have denominators the same, 4 and 4. So I can combine them already. Primary school teacher told me that over 4, numerator minus numerator. So x minus 3x, I get negative 2x. Less than or equal to negative 1. And then my primary school teacher also told me, 2 numerator, 4 denominator. I can simplify. So I take my pencil, this becomes 2. So now I end up with negative x over 2 less than or equal to negative 1. You can choose to remove the denominator 2, or you can choose to remove the negative sign, or you can choose to do both at the same time. So let me just do it step by step. Since this is our first homework question, I'm going to try and remove the negative sign first. I do so by either multiplying or dividing by negative 1. It has the same effect. So let me just multiply by negative 1. When I do that, immediately I change my sign first. Okay? When I multiply or divide by negative 1, I don't evaluate it. I quickly change the sign first. I don't want it to. I don't want myself to make careless mistakes and forget about it. So change already. And now I'm left with x over 2 with 1 on the other side. Now this is x over 2 greater than or equal to 1. I want to remove the divide by 2. So I need to reverse it to multiply by 2. X greater than or equal to 2. So this is the answer. And then they want us to represent it on the number line. So number line is just our x-axis. Okay, draw a horizontal arrow, label it x, because we're dealing with values of x. There is only one number that we're interested in on this number line. It is 2. So just draw a 2. Draw a circle. We are looking for x greater than or equal to 2. So we're looking for values to the right side of 2, including the value 2. So you circle it, you color it. What this means is that I am telling the marker, I'm telling all of you, hey, any value of x, as long as it is 2 or greater than 2, any of these values, doesn't matter all the way, it will satisfy the inequality. So let me now, because I'm so free, right? I'm going to substitute in values back to check. I'm going to try to check. Try x equals to 2. Try x equals to 3 for convenience. I'm also going to try x equals to 1. So this should not work, but the other 2 should work. Okay, because I'm so free, let me try now. 2, 3, and 1. So this is my original inequality. When I substitute x equals to 2 here, when I substitute x equals to 2 here, so take out a calculator, evaluate what is 2 over 7 plus 2 over 4. Can you help me find out? So this is my left hand side. 11 over 14. Okay, what about the right hand side? When I substitute 2 inside, so 6 over 4 minus 5 over 7, what do I get? 11 over 14? Yes, right? 11 over 14. Are you surprised? No. You see, 11 over 14, 11 over 14. There is an equal sign here, isn't it? So now I'm telling you, 2, x value of 2 works. It satisfies the inequality. So the next thing I wanted to try was x equals to 3. It should still work. Let me try it now. I'd rather let you all try it. Let's put a 3 inside here. So 2 over 7 plus 3 over 4. What do we get? And then the right hand side, 9 over 4 plus minus 5 over 7. Okay, can you tell me what's the left hand side? Those with the calculator. I still haven't found my calculator. I don't know where I left it. Some classroom. Oh, answer. 29 over 28, is it? Okay, so left hand side is 29 over 28. That is equals to 1 and 1 over 28. How about the right hand side? 43 over 28. So this is how much is it in mixed fraction? 1 and 15 over 28. So can you see that the left hand side? Yeah. Can you see that the left hand side is less than? See the left hand side value is less than the right hand side value. Can you see that? Yeah, so it satisfies the inequality. And then the last thing I want to check is, what if x is less than 2? Let's say x has a value of 1. Now I should have a case of left hand side not being less than or equal to right side. So let's just quickly try it. X equals to 1, so that we understand what is happening. When x is equal to 1, and then right hand side 3 over 4 minus 5 over 7. Okay, what's the left hand side value? 15 over 28. Right hand side? I think it'll be smaller. 1 over 28. So can you see now? Left hand side is greater than right hand side. It doesn't satisfy the inequality because I chose a value of x that is, I chose the value of x that is on the other side. 1 is over here. Okay? So it is very important to understand what you are doing, what the number line means, what you are trying to solve in an inequality. Okay, at this point, any questions? Anybody wants to ask questions, clarifications? If you understand what's happening, raise hand. Those who are staying on for the rest of the year. Understand, raise hand? Raise hand? Okay, let's move on to the next question. We have part H. So let me copy down the question first. 2h. 2 times of 3x plus 1 over 5 greater than or equal to 9x minus 1 over 8. Okay, so now solving this. Again, many ways you can start off with, but when I see numerators like this, I want to expand quickly. Taking care that the 2 is multiplied by a positive 1, and then 9 times x, 9 multiplied by a negative 1. Okay, all these drawings that if you're going to do, please use pencil so that you don't confuse the marker, you don't confuse yourself. So back to my pen, 6x plus 2 over 5 greater than or equal to 9x minus 9 over 8. Got a fraction greater than or equal to another fraction. So what I can do now is, on both sides, subtract our 9x minus 9 over 8 minus your 9x minus 9 over 8. So this will result in 6x plus 2 over 5 minus 9x minus 9 over 8 greater than or equal to 0. Okay, so this is one approach you can have. The other approach, if you want to try, is over here. The other approach, if you want to try, is to, after you expand the numerator, right, you split the fraction on the left-hand side. So it becomes a 6x over 5 plus 2 over 5. And then the fraction on the right side, you split it also, 9x over 8 minus 9 over 8. And then you group the x terms together. You can do that also. Okay? But let me just continue with this. I've got fraction minus fraction. You must remember what your primary school teacher told you. Fraction minus fraction. Same denominator. Don't be afraid. Don't think that algebra in secondary school is very scary, very confusing. No, it's the same. Make the denominator the same. Multiply by 8. Entire numerator multiply by 8. I highly encourage you to draw brackets for this. Denominator times 5. Numerator, the entire one, times 5. So if this, carry on, denominator the same. Over 40. Combine, combine, but do not expand. Please, do not expand yet. You can if you know what you're doing. If you end up with a lot of careless mistakes, especially when you're dealing with minus a fraction, if this always causes you to lose mark, this is the way to prevent it. You combine, but you don't expand yet. So 8 times of 6x plus 2 minus 5 times of 9x minus 9. Greater than or equal to 0. I know it is very tempting to straight away write 48x plus 16 minus 45x. Either plus or minus, depending on whether you know your stuff. Plus or minus 45. Okay, the correct answer is plus 45. But if you are not sure, combine, don't expand. At this point, then you expand. The negative 5, the entire negative 5 times 9 times the entire negative 9. Okay, so we have 48x plus 16 minus 45x. Negative 5 times negative 9 is positive 45. Okay, give you some time to copy this down first. Not done yet, Talk to your friends if you need help. Talk to me if you need help. Otherwise, I keep going on and on. You may not learn effectively. Any questions so far? Yes. Is it this part? Okay, then you wait first. Let me finish this portion first. Okay, now the next thing I want to write over 40 greater than or equal to 0. But think about it. Do I need to write over 40? If I write over 40 greater than or equal to 0, then my next step is actually to multiply by 40 on both sides, right? To remove the denominator, right? So what happens when I multiply by 40 to the right hand side? 0 times 40 is 0. On the left hand side, no more denominator, right? So instead of writing one step over 40 and then multiply both sides, right hand side still remain at 0, I know what's going to happen next already. I'm just going to skip one step, greater than or equal to 0. And now I group my x terms together. 48x minus 45x, that leaves me with 3x. 16 plus 45 is 61. Yeah, 61. So plus 61 greater than or equal to 0. I'm going to minus 61 on both sides, so negative 61. And then x greater than or equal to negative 61 over 3. Is this the correct answer? Well, very weird number. Okay, so x is greater than this number. My number line as shown. Label it x. X is greater than this particular number. The number is negative 61 over 3. So circle color to the right. Okay, so got a fraction minus fraction less than number plus fraction. We're going to use the same way. Fraction minus fraction. What should we do? Same denominator. Okay, I need you all to respond to me in class. I know I'm asking the same basic questions, but the truth is some of you may not realize it is just like that. So the more you say it, the more you believe in it, the easier it is for you to understand. So same denominator, I want it to be a 3. So draw bracket times 3 times 5, draw bracket times 5. On the other side, number plus fraction. We're going to do the same. Okay, so watch. 2 plus fraction over 1, 2 over 1. Denominator same, times 6 times 6. And then we carry on. On the left hand side, over 15. Do not expand yet, just combine. So 3 times of 2x minus 1 minus 5 times of x plus 1. This is less than 12 over 6 plus your x minus 2. Okay, at this step, then you combine. You expand. Do so this way with the negative 1, the negative 5, with the x and the positive 1. Giving us 6x minus 3 minus 5x minus 5 over 15. Less than 12 minus 2. That is 10 plus x over 6. Now we simplify the left hand side. 6x minus 5x. That is simply x. Minus 8 over 15. Less than 10 plus x over 6. Okay, now at this point in time, you may be tempted to do something like this. You know, you treat it like your equal sign, where denominator times numerator, denominator times denominator, left hand side equals to right hand side. But please take note, we're not dealing with equal signs over here. It is an inequality. So I would rather you take a safer way and you just do it step by step. Our objective is to remove the denominators. So let's start with the first one. Let us remove the 15. So we end up with, on the left hand side, x minus 8 less than 15 divided by 6 is divided by 3, 5 over 2. 5, 10 plus x over 2. Okay, 16 divided by 5 is just, 15 divided by 6 is 5 over 2, yes. Okay, all I did was just multiply by 15. Next step, I want to remove the over 2. Yes. Huh? Oh, okay. Let me, so I don't skip step for this side. So I multiply by 15, right? I end up with 15, 10 plus x over 6. Agree? Then I cancel. 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 Divide by 3, I get 5. Divide by 3, I get 2. Okay? Ready? If you all don't understand, must say. Then I must ask, then I can tell you. Okay, now I want to remove the over 2. So I multiply by 2 times 2. So 2x minus 16 less than, now I'm going to expand already. 5 and 10, 5 and x. So that is 50 plus 5x. Other approach also can work. If your final answer is same as mine, then pretty sure yours is correct. Unless you have mistake with another mistake, then the mistakes cancel off. Okay, so I only want my x to be on the left-hand side. So minus 5x, minus 5x. But because I do a lot of algebra already, I know later on I need to get rid of the negative 16. So I plus 16 at the same time. Okay, so I combine two steps. So 2x minus 5x is negative 3x. Negative 16 plus 16 is nothing. So that's my left-hand side already. 50 plus 5x minus 5x, no more 5x. 50 plus 16 is 66. And now I do not want the negative 3. I don't want this. So on both sides, I need to divide by a negative 3. Divide by negative 3. When I divide by negative number, straight away change the sign so that I don't forget. Less than becomes greater than. On the left-hand side, I'm left with x. On the right-hand side, I'm left with negative 22. Is it the correct answer? So check. So I'll keep asking. Okay, so x is greater than negative 22. So circle, the circle, don't color. Okay, because we are excluding the value of negative 22. Recap on the question. There are some metal spheres, masses 20 grams each. The box mass 150 grams. This guy, he places n spheres. I don't know how many spheres, but he places some of them inside. Expressed in terms of n, the total mass of the box and its spheres. Okay, part A is quite simple. Total mass will be our box plus 20n. All these with the units gram. Okay, so B part 1. Now they tell us that the total mass of the box and the spheres is more than 290 grams. It is more than 290 grams. And then they ask you to form an inequality in terms of x. Don't let it scare you. You really just translate the English over there to mathematics. Total mass. Total mass more than 290 grams. We already have an expression for total mass. So we just copy that down. 150 plus 20n. And they said that more than. Is this inequality simple? That's all. Nothing difficult. More than how much? 290. Part A finished. Part B, part 1 finished. They ask you to form. Part 2. Find the smallest value of n. I know they ask you to find the smallest value, but basically you just solve the inequality that you obtained, part 1. So on both sides, we want to subtract 150, leaving us with 20n greater than 140. I think the answer is quite obvious already. Now, we need to remove the 20 by dividing by 20. So we have n greater than 7. N is greater than 7. Take a few seconds, make sure you understand what's happening. N is greater than 7. N refers to the number of spheres. Our mathematics in part 2 tells us that the number of spheres is more than 7. More than 7 cannot be 7. And then they ask us for the smallest value of n. So what is a number that is greater than 7 by the smallest? Yeah, 8 lah. We cannot have 7.1 sphere, right? We cannot have 7. We cannot have 6. So smallest n is 8. Okay, the next one, question 7. Yeah, pause for that, let you all understand it first. And then a lamp of half ampere is already plugged into the power board. X hair dryers, each of them 3 amperes are now plugged in. Find the total load. Are you familiar with amperes? Are you familiar with it? You learned already this year, is it? You learned it this year or last year? Okay, then okay. So now we're going to add them up. Total load. So we have our half that belongs to a lamp already, plus there are X hair dryers of 3 amperes each. 1 hair dryer 3 ampere, 2 hair dryers 6 ampere. X hair dryers, X times 3. Yeah. So 3x amperes. This is the total load. Oh, done. Part A is done. Then part B, it says form an inequality so that the power board is not overloaded when all of them are turned on. So that it is not overloaded. That means the total must be less than, wrong. No. The total must be not just 13. Is a range. Less than or equal to 13. You cannot say less than 13 because if you say less than 13, you are excluding 13. You cannot say less than 12.9 because if you say less than 12.9, you are excluding 12.99. So you have to use the correct term, less than or equal to. Okay, so total load half plus 3x less than or equal to 13. And then the same thing happens again. Remove the half. So 3x less than or equal to 13 minus half. So that's 12 and a half. 25 over 2. Then we want to remove the 3 times. We divide by 3. So x is less than 25 over 6. 25 over 6 is improper fraction. It doesn't really tell me. It gives me the feeling of how many hairdressers I can. Oh, wait. Sorry. This is part C already. Part B stops here. Part B is just form equality, and then part C says hence find the maximum. I just did extra already. Okay, so part C we carry on to solve, and x is less than or equal to 25 over 6. 25 over 6 is an improper fraction. It doesn't tell me very clearly what is the maximum number of hair dryer. So another form that is more useful is either decimal or mixed fraction. These will be more useful in telling me what is the maximum number. So x less than or equal to 4 and 1 over 6 hair dryers. So what is the maximum number of hair dryers I can have? 4. Okay, because I cannot have 4 and 1 over 6 of a hair dryer. Therefore, the max number is 4. And when you do enough problem sums, you have to realize that eventually your last step, the inequality sign, it has to make sense. Okay, I see that you're all done writing already. Now look at me, listen carefully. When you're doing problem sums on inequalities, the last step has to make sense. They're asking for the maximum number of hair dryers. your inequality sign should show x less than or equal to 1 and 1/6. Can you imagine if you end up somehow, all your working, you do, you get x greater than or equal to 4 and 1/6. Think about it. If this is your final answer, and then you are trying to answer the question, find the maximum number of hair dryers. X is the number of hair dryers. What are you going to conclude from this? No, x is greater than or equal to 4 and 1/6. What is your conclusion if they ask for maximum number of x? Maximum is the biggest number. Tell me, what's the biggest number of x that will satisfy this inequality? Infinity, yeah. Right or not? Look, x greater than or equal to 4 and 1/6. If my working shows me this, and the question asks me for the maximum number, then x has to be infinity, isn't it? But can that make sense? No, it cannot make sense. Somewhere my working went wrong already. So what I'm trying to tell you is that if you do it correctly, in blue, the final inequality should correspond and make sense. Okay? If this happens to you in red color, check your work again. Let me illustrate with the previous question also. So in question 6, remember we were talking about the number of spheres inside the box, right? The question asks for the smallest value of n. The smallest value of n. My final answer is n greater than 7. So I could give them the smallest value of n. But what happens if I made some mistake and then I ended up with x less than 7? And then the question asks me for the smallest value of n. Tell me. Not x, n. My working tells me n less than 7. The question asks for smallest n. So what should my answer technically be? Smallest n. N is less than 7. What is the smallest value of n? This is 0. Something is a negative number, right? Negative 1 is the smallest. Negative infinity. Does that make sense? Doesn't make sense. Somewhere my working was wrong. So check your work. Okay, so question 7 finished. Any questions? Session okay? Learn, understand already? Okay, then we move on to 2.3, simultaneous linear inequalities. Does the name scare you? Why? What does it remind you of? Simultaneous equation. Okay, so let's do a quick recap on our understanding of simultaneous equation. I'm going to create two equations. So let's go with 3x plus y equals to 7, as well as negative x minus 3y equals to 10. For example only, how are we going to solve this? In fact, when they ask you to solve the simultaneous equations. What does it mean actually when they ask you to solve the simultaneous equation? Find y, find x. Okay. Correct. Is there anybody who wants you to explain what does it mean? Raise hand, then I'll explain. Otherwise, I just move on. Anybody wants me to explain what it actually means? Not that I know how to do, but what it actually means. Explain? Explain, okay. 3x plus y is equal to 7. There are infinite numbers of x and y that will make it true, isn't it? Infinite number. If x is equal to 0, y is equal to 7. If x is equal to 1, y is equal to 4. If x is equal to 2, y is equal to 1. There are infinite solutions. Okay? And we can plot them on a graph. Likewise, for the second equation, there are infinite possibilities. If x is equal to 1, y is equal to, I don't know, I go and work it out. X is equal to 2, y has a certain value. But there's a keyword, simultaneous. What does simultaneous mean? No, don't tell me in method. What does it mean in English, simultaneous? At the same time, yes. Simultaneous means at the same time. I am looking for x and y values that will satisfy both equations at the same time. Okay? Individually, they have their own x, their own y, but there is one particular value of x and one corresponding value of y that will make both equations true at the same time. So that's what simultaneous equations mean. Okay, so knowing that there is only one value of x with one corresponding value of y, we go ahead and we do our either your substitution or your elimination. What do you like? Substitution or elimination? You like elimination? Then I do substitution. Okay, so because you need to know both, from equation number 1, y is equal to 7 minus 3x. Let us call this equation number 3 sub into equation number 2. So standard way of solving simultaneous equation. I want to pause here first. Okay, so sub equation 3 into equation 2, negative x minus 3. When you see the y, you change it to 7 minus 3x equals to 10. And then you expand, negative x minus 21 plus 9x equals to 10. Combine, 8x is equal to plus 21, 31. X equals to 31 over 8. Now we end up with a single value of x. This is the value of x that will satisfy both equations at the same time. But it has to have a corresponding value of y. So we sub into the equation that are newly created, equation number 3. So it says that y is equal to 7 minus 3 times of 31 over 8, and you get answer. So you have an x and y that was a what? Y? 31. Because I revoked the negative 21 by adding 21. Okay, no problem. Very good, your questioning. Okay, so we have our x and y value that will satisfy both equations at the same time. In other words, simultaneously. With this understanding, now we can do our simultaneous linear inequality. Okay, so let's try and understand what's happening. So simultaneous means at the same time. Linear inequality is something that we have been doing already, and now there are at least 2 inequalities that you have to work on. Okay, so let's take a look at example number 6. We start slower. Find the solution to each of the following pairs of simultaneous inequalities. Represent on the number line. So look at the screen now. I don't care, you got tuition, learn before, don't know what's happening, you look at the screen now. Part A. We have 2 parts to it. Obviously, simultaneous one, so you need at least 2 of them. X greater than negative 2. Okay, the first portion is x greater than negative 2. On the number line, it is shown over here, x greater than negative 2 with a hollow circle. That means I don't color it, hollow circle. The highlighted portion says that everything to the right hand side is a solution to x greater than negative 2. And it totally makes sense, right? Negative 1, 0, 0.8, they are all greater than negative 2. But there is a second part to that question. It says that x is at the same time greater than 4. So let me draw my number line. Oh, x is greater than 4 is found over here. Okay, that means x can be 4.1, 4.001, 4.8, 5, 10, infinity, 10. That is why we have an arrow pointing to the right, because I cannot draw all the way, right? Draw the arrow very long, right? So I just end off with an arrowhead over here. So now our number line shows us 3 regions. Where are the 3 regions? Watch carefully. This is region region A. This is region B, and this is region C. Can you see that? We have 3 regions, 3 portions to it. It is in part A. How do we describe part A? How do we describe A? X is less than negative 2, right? Now, whether you say less than or equal to or less than, doesn't matter. I just need to understand that on the left hand side is less than -2. What about region B? What does it show? -2 to 4. There are boundaries. There's a lower boundary, there's an upper boundary. And then region C is greater than 4. And all the way, right? Okay, now, which of these regions, A, B, or C, satisfies both inequalities at the same time? A, B, or C? Can you see that? Okay, let's break it down. Correct answer is C. A. Does A satisfy yellow color? No. Does it satisfy the green color? No. B. Does it satisfy the yellow color? Yes. But does it satisfy the green color? No. So is it simultaneous? No. How about C? Does it satisfy yellow? Yes. Does it satisfy the green? Yes. And therefore the answer is the green color, the region C. And how do we describe region C? Look carefully. Region C is over here. Do you see that circle over there that is not colored? Are we allowed to include that value? Can include? Can or cannot? Think. Okay, the answer is cannot. You cannot include the 4 because the second part of the simultaneous inequality already tells you it is greater than 4. You cannot have 4. Even though the red color arrow tells you, hey, you can include the 4, can, but the other one cannot. So at the same time, means cannot. Okay, so the answer, very simple, x greater than 4. That's the answer. It's just like that. Okay, and we have, let's take a look at part B. Part B says x is less than 1, less than or equal to 1. So same thing, number line, you will find that it is very useful in this. In fact, draw it. X less than or -1, less than or equal to -1. X less than or equal to 7. So this is the next region. So again, 3 regions, A, B, and C. Where is my answer? A, B, or C? A. It has to satisfy both. And then once you decide that it's in A, you look closely at this one over here. Can I include the 1? Can or cannot? Can. In both arrows, 1 is included. Therefore, my solution is x less than or equal to 1. Simple? Yeah, because it's the basic lah. Okay, next one. X less than 5, x greater than or equal to -1. So x less than 5, this one is more interesting. Less than 5 with a hollow circle. Please take note. And then we have x greater than or equal to -1. X greater than or equal to -1 over here. Can you see 3 regions again? Can see or not? Okay, now I'm going to cut them. Region A, region B, and region C. Where is my solution? A, B, or C? B, because simultaneous inequalities. Both have to be satisfied at the same time. Only B has yellow and green highlighted regions. Okay, and how then do we describe this region? You have to look closely and consider the endpoints. Let's look at the -1 first. Okay, can I include -1? Yes, so x is greater than or equal to -1. Let's look at the upper boundary, 5. This is included. How about this? So is 5 included? No, it is not included. Therefore, the inequality sign is as such. Okay? Any questions? Any questions? No? Then I will show you now a very common mistake. X, how they usually do it. Okay. What do you think of this? Blue color answer. Okay or not okay? Okay or not? Five is more than x, which is more than or equal to -1. Okay, is this okay? Okay. Okay. The answer is this is not the sequence, yeah. Usually you put small number on the left, right? But then now what do you see what happened? Yeah, the 5 is on the left hand side, and then the smaller number is on the right hand side. So this one actually not too bad lah. But we don't want you to write it this way, okay? Put a small number in front. I show you worst mistakes, huh? This 5 and -1. Does this make sense? Does it make sense? So x are supposedly bigger than 5, but then it's less than -1. Does it make sense? No. Okay, so this one, the one, this one, the one. And then you'll see things like this one. Wow. I don't know how. Or the inequality sign, anyhow one. Don't give me any of this, I only want inequality signs if we're talking about region B, that means the center region where you have a lower and upper bound. I only want my inequality signs to look like this. Smaller number on the left, bigger number on the right. Okay? Only this is accepted. Everything else, I will just mark wrong. Yes. No inequalities in 2. Okay, so can be both. So this is, like I said, this is what I'm going to accept. The smaller number on the left, if it has a lower boundary and an upper boundary. However, when you're doing, sometimes your answers look like this. X greater than 3. This is fine. You only have one value, 3. So your inequality sign, I'm okay with it. In fact, it should be pointing in this particular direction because we make X the subject. Okay, please don't leave your answer like this, You don't do this, right? When I ask you for value of X in algebra, you do your working, you will tell me that X equals to 13, right? You wouldn't say 13 equals to X, isn't it? You wouldn't. So we make X the subject. Always make X the subject. So inequalities with this answer is okay. Inequalities with let's say -1. No, this is not okay. This is okay. X less than -1. This is okay. All right. The inequality sign can be either way, as long as you only have one boundary. But when your X is in between 2 numbers, I only want it to point in this direction. Don't give me anything else. All right. The whole idea is smaller number on the left. That's all. That's all that there is to it. And then let's look at part D. Okay, part D. I want you to think with your partners. Okay, X less than or equal to -9. Understand what it means? X less than or equal to -9. Make sure you understand. And then at the same time, I want X to be greater than 0. Can you think of a number that satisfies both at the same time? Think and think and think. Take some time to think. Talk to your partner. Must be more than 0, but must be less than -9. Oh, anything? Any answer for X? Don't have. Don't have. There's no answer. There's no value of X that will satisfy both at the same time. Let's look at what our inequality, our number line tells us. X less than -9, so it is over here. And then X is greater than, so it's over here. Again, I divide into 3 regions: A, region B, region C. Is there any region that has both at the same time? Don't have. There is no intersection. There is no intersection. So this is another keyword, intersection, commonly used with simultaneous equation. Because when you have your simultaneous equation, you have 2 lines. They intersect over here. This is your line 1, this is your line 2, y equals to 3x plus 1. This is your y equals to negative x plus 8, for example. They intersect over here. This is our x value. This is a y value. These values will satisfy both equations simultaneously, the intersection point. Over here, in example D, there is no intersection. Whereas in example A, B, and C, we do have intersection regions. Okay, so with that, you are going to now try it 6. Part A first. Okay, do it now. You can do it on a textbook. Okay, so here we have x greater than 0, x greater than 3. So this is how I do it. This is my working. And then my final answer, x 3. Okay, so this is my answer. This is working. So as long as x greater than 3, you're satisfied. Okay? Okay, move on. The rest B, C, and D, right, is actually just the same concept as what was in your work example. Okay, so now let's take a look at example number 7. Look at the screen. Example number 7, solve the inequalities. So you have your first inequality and your second inequality. I'm sure you know how to evaluate, simplify the first one, you know how to simplify the second one, such that you end up with x less than 3, x less than 5. It's just very basic manipulation. So once you reach this step, you draw your number line and you decide which region to take. So in this case, this is our answer. Okay, so this is how we do simultaneous inequalities when they're given to you like this, 2 of them. I think this this is the next one. So it gets a little more complicated, which is what you have already practiced in exercise 2.2. We have done this inequality before, this style. In both cases, you just work until you just work on them independently. And then you combine the answers together. Okay, you solve the inequalities by themselves. And then you find the solution. Like I said, they always point in this particular direction. I'm not going to go through this. Okay, this is the one I want to show you. Okay, example number 9. Take a look at this. Okay, look up. Very important is your homework question. One of your types. Here, you have expression, inequality, expression, inequality, expression. Where are the 2 simultaneous equation inequality? You really got 2, right? This one never show any. So where? I'll show you. This is the first one. Can you see inequality? So I can solve, right? Simplify it. The other one is found here. Can you see that? Yeah, 2 simultaneous equation, inequality, solve. Okay, so with this, you are set for your homework question. So they are over here. Please copy them now. Question 1A, 1H. For those of you who don't have your textbook, I suppose your friend will take photo of the questions and send to you. Okay, 1A, 1H, 2D. One A, 1H, 2D, 2F. And then question 3 and 7. Okay, any questions? And 7 as well as 7.